Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Want to remind you that I'm at upcoming CBPCon and NDC TechTown conferences for workshops. In this episode, I want to talk about the range of values of enumerations, and we're going to look into what this means and how it is checked by our compilers and undefined behavior, or perhaps unspecified behavior, and constexpr evaluation. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance. And they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. This is C++ 26, so we can do this handy const eval block. I don't actually need C++ 26 for this, but this surely is a handy way of doing these things. Oh, I don't have the reflection fork, so we're not going to use a const eval block. That's fine. We'll do the moral equivalent of an immediately invoked const eval lambda. Anything that happens in here is going to be const eval, and therefore we're going to get compile time errors. I'm going to declare an enumeration. And the question that you might want to ask yourself is, what is the range of vals? This is a C-style enumeration. The rule actually says that the valid range is the minimum number of bits necessary to hold all values. So let's go ahead and try this. I'm going to create an object of type vals. And I am going to static cast to vals the value 1. This should be totally fine. 1 is in there. And so what is the minimum number of bits here? This needs to be able to hold the values 1 and 2. So that is 2 bits. And let's see what happens. So I create one with the value 0. That's fine. 1, we already tested. 2 should also obviously be fine. And then we're going to try value 3, and that can fit within 2 bits. Let's try value 4, which requires 3 bits. And now I get a compile time error. Integer value 4 is outside the valid range of values for the enumeration type of vals. Pretty darn neat, don't you think? So we can actually test the fact that this is the valid range of things. So if I were to make 4 be the next value, then the minimum number of bits necessary to hold this would be 3 bits. And the upper range of 3 bits should be the value 7. So the value 7 should work here, and the value 8 should fail to compile again. Isn't that cool? This is a nice, handy, neat check from Clang that it is actually enforcing this rule in constexpr of no undefined behavior at compile time. So if I were to make an enum struct vals2, and I am going to do the same thing here, this should compile just fine, because the underlying type of an enum struct or enum class is by default int. So this is fine. I can make this, some large number that's less than 4 billion, basically, and that's not going to be a problem. Now, I could make the underlying type char, at which point this should fail to compile again. Oh, it is not failing to compile. That probably is because I'm using a static cast. So let's do braced initialization and see what kind of result we can get from it. Now, constant expression evaluated to blah, 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 which cannot be narrowed to type vals2. All right, let's see if we have values that can be narrowed to type vals2. We can. 4, yes. 153, 145. So this is going to depend on your particular platform as to whether or not car is signed or unsigned. Let's make the underlying type an unsigned car. If it's a signed car, then the maximum value should be 127, or I can do negative 128, I believe, if I have my 2's complement math correct here, but negative 129 is going to fail to compile. All right, so there you go. These are going to be caught by your compiler at compile time if you are using a compiler that checks for this during constant evaluation. I personally find this particularly neat. I love having additional tools in my tool bag that help me to verify that my code is correct. And this also kind of helps solves, a little bit of argument because people don't understand the rules for what the valid range of values are for enumerations. It is not what is declared here. It is what the language actually specifies. So just to keep things slightly confusing, let's go ahead and return the result of this. And the return value that I'm going to return here is the return size of vals. And you will see that the size is 4. So it is actually using a 32-bit integer to hold the thing, but you're not allowed to have anything bigger than, in this particular case, 3 bits. So thanks for watching this episode of C++ Weekly. I'll be sure to have this in the notes so you can go play with it yourself, and I will catch you at an upcoming conference.